Right now, without you doing anything at all, you are hurtling through space at 230 kilometers per second. You've been doing it your whole life. Your parents did it. Every human who ever lived did it, and none of them knew. All 8 billion of us, orbiting the exact same invisible point, something so extreme it shouldn't exist. And yet here we are. But here's the thing, nobody tells you right now, as you're watching this, that thing at the center of our galaxy is asleep, and the last time it woke up, it tore through our galaxy with the energy of 1,000,000 suns, and the light from that event is only just reaching us now. Which means everything you think you know about the quiet heart of the Milky Way is based on a lie, a 26,000-year-old photograph. We'll come back to that because when we do, it'll completely change how you see the night sky forever. But first, our monster at the center isn't even close to the most terrifying black hole in the universe. Some are the size of a city, drifting silently through our galaxy right now, closer than you'd be comfortable knowing. Others are so stupidly massive they anchor entire galaxies, billions of suns crushed into a single point. And then there are the ones predicted by equations but never yet seen objects that might be the actual fabric of dark matter itself. Today we are going all the way, every type of black hole, the science behind them, the humans who risked everything to find them, and the one revelation about our own galaxy that changes everything. Let's get into it. Before we climb the hierarchy, you need to understand what a black hole actually is, and I mean really is, not the movie version. A black hole is a region of space where gravity has gone so completely off the charts that nothing, not matter, not light, not even information can get out. Imagine compressing the entire mass of our sun into a sphere a few kilometers wide. The gravitational pull becomes so intense it literally bends the fabric of space and time around it. There's a boundary around every black hole called the event horizon, the point of no return, where even light gives up trying to escape. Cross that line and you are done. Your ship, your last text message, all of it gone forever. Now here's the misconception that drives physicists absolutely mad. Black holes are not cosmic vacuum cleaners roaming around, hoovering up everything in sight. They just sit there. If you wander too close, that's on you. Gravity does the rest. They're not villains. They're the inevitable outcome of physics being pushed to its absolute limit. And the thing that genuinely blew my mind when I first went deep on this, not all black holes are remotely the same thing, not even close. There's a whole hierarchy, 5 completely different categories, each weirder than the last, and we're going to climb everyone. Starting at the bottom, stellar black holes, the most common and the most personal. When a star, at least 20 times the mass of our sun, burns through its fuel after millions of years, it doesn't quietly switch off. The whole thing collapses inward in a fraction of a second, then bounces outward in one of the most violent explosions in the known universe, a supernova. If the leftover core is heavy enough, the collapse keeps going through every known threshold of pressure, heat, and resistance until nothing is left but a black hole. Typically 5 to 100 solar masses, all compressed into a region smaller than the city you're probably sitting in right now. Our galaxy is thought to contain somewhere between 10 million and 1 billion of these things silently drifting through the dark between the stars. We find most of them when they're locked in orbit with a companion star, slowly stealing its gas, which heats to millions of degrees and blazes in X-rays bright enough to spot from Earth. They're the bread and butter of black hole astronomy, well understood, well observed, and genuinely everywhere around you, all the time, whether you think about that or not. But stellar black holes are the bottom rung. Let's go up. Skip several rungs and you land on the supermassive black holes. And this is where things get properly, irreversibly mental. Not a few times the sun's mass, millions, sometimes billions of times the sun's mass, crammed into a single point in space. These things sit at the centers of virtually every large galaxy we've ever looked at, including ours. and nobody fully understands how they got so enormous so fast. The one you're personally orbiting right now is called Sagittarius A star, and it sits about 26,000 light-years away, weighing in at 4 million times the mass of our Sun. And for most of human history, for every civilization that ever looked up at the night sky, it was completely, utterly invisible. The reason between us and the galactic center sit enormous clouds of gas and dust that block every wavelength of visible light completely. Point any normal telescope at the center of the Milky Way, and you see absolutely nothing, just blackness, as if there's nothing there. The first crack in that wall came in 1974, when radio astronomers Bruce Balick and Robert Brown found something bizarre, a powerful, impossibly compact radio source right at the galactic center. Too bright to be a star, too small to be a cluster, too intense to be gas, they named it Sagittarius A star, and nobody knew what it was. The smoking gun took another 2 decades and 2 of the most stubborn scientists on the planet to find. In 1994, a young astrophysicist named Andrea Ghez at UCLA and a German astronomer named Reinhard Genzel at the Max Planck Institute independently decided to do something that looked, frankly, insane. They pointed their telescopes at the galactic center using brand new infrared cameras that could pierce the dust, and they just waited. Year after year, image after image, they tracked individual stars near the galactic center, not hundreds of stars, just a few dozen, watching them move. And those stars weren't drifting, they were whipping around something invisible in tight, violent, elliptical orbits, like planets on steroids. One star in particular, a blue-white star they called S2, became the key. S2 completes a full orbit every 16 years. And at its closest approach, it screams past the galactic center at nearly 3% the speed of light, that is 9,000 kilometers per second. When you do the maths on an orbit that fast, in a loop that tight, there is only one possible explanation: an object of 4 million solar masses compressed into a region smaller than our solar system. Not a star cluster, a black hole. Full stop. Both teams published their findings independently. Both came to the same conclusion, and in 2020, Andrea Ghez and Reinhard Genzel were awarded the Nobel Prize in Physics for what became one of the most rigorous proofs in modern science. Ghez became only the 4th woman in history to win a Nobel Prize in Physics for spending 26 years patiently watching stars orbit an invisible point. Then, in April 2019, came the image that made the whole world stop. The Event Horizon Telescope collaboration released humanity's first ever photograph of a black hole. It wasn't our black hole first. That honor went to M87 star, a monster 6.5 billion times the mass of our Sun, in a galaxy 55 million light-years away. That iconic orange ring of superheated gas, surrounding an impossibly dark shadow that was not CGI. Not an artist's impression. Not a simulation that was a real photograph. And then in May 2022, the team turned the camera home and released the first image of Sagittarius, a star itself. It was harder to capture. Sgr A star is far more turbulent, its gas flickering on timescales of minutes, like trying to photograph a raging campfire instead of a slow-burning furnace. But they got it, and there it was. For the first time in the entire history of our species, we could see the thing we've been orbiting all our lives. Now here's where I need you to pause and sit with something, because this is the part most science videos skip right over. That photograph of Sagittarius A, star, the one that made headlines around the world, is already 26,000 years out of date. The light in that image left the galactic center when our ancestors were still painting cave walls in the Stone Age. We have absolutely no idea what Sagittarius A star looks like right now, and what we know about its history suggests the current picture is deeply, disturbingly misleading. Because Sagittarius A, the thing we describe as relatively quiet and currently dormant, has not always been that way. Evidence from X-ray echoes bouncing off dust clouds near the galactic center shows that just a few hundred years ago, a blink of an eye in cosmic time, Sgr A was over 1 million times more luminous than it is today. It was erupting, flaring with the violence of an active quasar, blasting radiation across the galaxy, and that outburst lit up the surrounding gas clouds like a cosmic flashbulb. We can still see those echoes today, faint X-ray reflections bouncing around the galactic center like the light from a storm that already passed. So the quiet black hole in our photographs is actually a sleeping giant, and nobody knows when or whether it will wake up again. That's the open secret sitting at the heart of our galaxy. We're orbiting something that has erupted before, will likely erupt again, and the light from its last tantrum is still bouncing around out there right now. Keep that in the back of your mind as we keep climbing, because it connects to something we'll come back to at the end. Now, between stellar black holes and supermassive ones, there's a conspicuous gap that physicists have been quietly losing sleep over: intermediate mass black holes. A few hundred to a few 100,000 solar masses too heavy to be stellar remnants, too light to anchor galaxies, and for years scientists weren't sure they existed at all. They're the missing middle child of the black hole family, the piece that's supposed to explain how stellar black holes eventually grow into supermassive ones, but which nobody could actually find. In recent years, though, the evidence has been stacking up: anomalous gravitational wave signals, dense star clusters with suspiciously strong gravitational pulls at their centers, and a handful of ultra-luminous X-ray sources that don't fit any other explanation. They're still elusive, still contested, but the hunt is very much on, and every new gravitational wave detector we switch on makes them harder to hide. Now let's get into properly weird territory: primordial black holes. These wouldn't have formed from dying stars, they'd have formed in the first fractions of a second after the Big Bang, before a single star ever existed. In those insane early moments, the universe was a seething, almost incomprehensibly dense soup of energy, and in certain regions the density fluctuations could have been large enough to collapse directly into black holes. Primordial black holes, if they exist, could range from subatomic scales all the way up to thousands of solar masses, fossils from the very first instant of creation. And here's where this connects back to the galaxy-shaped problem we've been building toward the one nobody has properly solved. We know from observations that billion solar mass black holes already existed less than 1 billion years after the Big Bang, and stellar black holes simply have no business being that large that fast. If primordial black holes were already out there acting as seeds, massive starting points that the growing black holes could build from it would solve that mystery in one shot. But here's the genuinely exciting part: some physicists think primordial black holes might actually be dark matter, all of it. Dark matter makes up roughly 27% of the universe. It doesn't interact with light. We can't see it. We can't touch it. We only know it's there because galaxies rotate in ways that make no sense without it. If primordial black holes are the right size, small enough to have survived to today without evaporating, their collective gravity would account for every single one of those mysterious effects. It would mean dark matter isn't some exotic new particle, it's just black holes we made at the beginning of everything. We haven't found direct proof, yet scientists hunt them through gravitational lensing, watching for tiny distortions in starlight when one passes in front of a distant source, but every new telescope gives us another shot. If we ever catch one, it wouldn't just be a discovery, it would collapse 2 of the biggest unsolved problems in physics into a single answer. Now hold on tight, because the next level is where physics goes completely off the rails: quantum black holes. This is the frontier where Einstein's general relativity and quantum mechanics crash into each other head-on. And here's the issue: these two theories are the most successful, the most rigorously tested frameworks in the entire history of science. General relativity has predicted everything from GPS satellite corrections to the existence of gravitational waves every test it passes. Quantum mechanics underpins every computer chip, every MRI scanner, every laser on the planet. Its predictions are accurate to more than 10 decimal places. And when you try to combine them at the scale of a quantum black hole, they flat out contradict each other, which means at least one of them is wrong. And we don't know which. Quantum black holes would exist at the Planck scale, around 10 to the minus 35 meters, incomprehensibly smaller than a proton, yet with a density that forces both sets of physical laws to apply at the same time. They'd also evaporate almost instantly, thanks to a mechanism called Hawking radiation, an insight from Stephen Hawking showing that black holes slowly leak energy through quantum effects right at the event horizon. For a stellar black hole, Hawking radiation is laughably slow. It would take longer than the age of the universe to lose any meaningful mass. But a quantum black hole would be gone in a blink, a flash of energy. They're nothing, which is why they're so brutally hard to study, even theoretically. Some physicists have speculated that the Large Hadron Collider might briefly create them in high-energy collisions, though so far, no evidence. And if it did, they'd vanish before any detector could catch them. Their real value isn't in what they do to the universe, it's in what solving them would give us the unified theory of everything, the single framework that reconciles relativity and quantum mechanics once and for all. The answer to the deepest question in physics, what is reality actually made of at the smallest possible scale, might be hidden inside an object too small and too fleeting to ever directly observe. And that's the kind of maddening, beautiful problem that keeps physicists going. Before we get to the ending, and trust me, we are circling back to the sleeping giant, two bonus entries that deserve their moment. Binary black holes, pairs of black holes locked in an orbital dance, spiraling toward each other over billions of years until they collide in the most violent event the universe produces. When two black holes merge, the energy released in that fraction of a second exceeds the combined light output of every star in the observable universe, and that energy ripples through the fabric of space-time as gravitational waves. In September 2015, LIGO picked up those ripples for the very first time, confirming a prediction Einstein made in 1916 and opening an entirely new way of listening to the cosmos. We can now hear black holes collide a billion light-years away, which is one of the most audacious things our species has ever pulled off. And then there's the strangest entry of the lot white holes, the theoretical mirror image of a black hole. If a black hole is an object that nothing can escape, a white hole is an object that nothing can enter. Matter and energy are only expelled from it, never absorbed. They drop out of the same equations that give us black holes, and some theories connect the two through a wormhole, a tunnel punched through space-time itself. Nobody has ever observed a white hole. Most physicists doubt they exist in nature, but they are genuinely permitted by the mathematics, which means we can't fully rule them out. They are the universe's outstanding what-if, the question the equations keep asking us that we can't yet answer. Right, let's come back to the thing I opened with, because now you have all the pieces and it hits completely differently. Sagittarius. A star is described in most textbooks and most documentaries as a relatively quiet black hole, sedate, dormant, a sleeping giant. But what we've since discovered is that a few hundred years ago, so recently, that the light from the event is still echoing through nearby gas clouds, it erupted with cataclysmic force. Those X-ray echoes are called Sgr A star light echoes, and they're a direct record of a violent flaring event that our galaxy's center threw off while our ancestors were writing the first history books. And we're not just talking a modest flare. Researchers estimate the eruption was over 1 million times more luminous than what we observe today. Brief, but absolutely ferocious. The photograph we took in 2022, the one on every news website, in every textbook, our first look at the heart of our galaxy, that's what it looked like 26,000 years ago, during a relatively quiet phase. What it looks like right now, today, at this actual moment, we genuinely don't know. The light carrying that information is somewhere between here and the galactic center, and won't reach us for another 26,000 years. We are, in the most literal sense, living in the past of our own galaxy, watching a movie that's already 26 millennia old. And I think that's one of the most extraordinary, quietly humbling things about all of this, that our species, right now, at the peak of our scientific power, is still only seeing echoes. We built a telescope the size of the Earth, won Nobel Prizes, photographed something that shouldn't be photographable, and we're still looking at a shadow of a shadow of a shadow. And yet the story keeps getting richer, because every layer we peel back reveals something stranger and more connected than what came before. Stellar black holes scattered through the dark, forging the heavy elements that eventually end up in you. Every atom of iron in your blood was cooked in a star that died this way. Supermassive black holes regulating entire galaxies, turning star formation on and off across millions of light years, sculpting the universe at the largest scales we can measure. Primordial black holes possibly threading through everything as the invisible skeleton of dark matter, the very architecture the universe used to build itself. Quantum black holes standing at the border of everything we know, waiting to crack open a unified theory of reality if we can ever figure out how to ask them the right question. None of these are just objects in the sky. They are the mechanisms the universe runs on, from the first microsecond of the Big Bang to the last star that will ever burn out. And the humans in this story, Genzel. The 300-person team behind the Event Horizon telescope didn't work on this because it was useful or profitable. They did it because some questions are so enormous, so fundamental, that the act of asking them is its own justification. The next generation of instruments, the extremely large telescope in Chile, the LISA space-based gravitational wave detector, the upcoming square-kilometer array, are going to fundamentally rewrite what we know. We may catch a primordial black hole in the act, or detect gravitational waves from the Big Bang itself, or watch Sagittarius A star flare in real time as it pulls in new material. The universe has been keeping its darkest secrets for 13.8 billion years, and we are, right now, in the middle of cracking them open. So the next time you step outside on a clear night and find that faint smear of the Milky Way stretching across the sky, really look at it. Somewhere in that haze, hidden behind 26,000 light-years of gas and dust, is a 4 million solar mass black hole pulling every single atom of you in a vast, silent orbit. You're not an observer looking up at the cosmos. You are part of the cosmos, moving inside it, shaped by it, made from the debris of the very stars it consumed. You are orbiting the heart of the galaxy, made of the ashes of its stars, looking back at a light that left before your species existed. And somewhere out there, right now, the real version of all of this is happening raw, unobserved, 26,000 years ahead of anything we'll ever see. That's not terrifying. That's the most extraordinary thing I've ever heard. And that honestly is the most metal thing in the entire universe.